All right, folks. Get through this here. All right. So, first of all, if you don't already have your periodic table annotated, um, let's go ahead and take care of that. Let's see. All right. So, all the metals, all the metals have positive charges. So, for example, let me change the size of this guy here. +1 for hydrogen, lithium, and sodium. So this whole family. I'm going to do a different color too. +1 for that. +2 for barium, beryllium, magnesium, calcium. Now we're going to skip these right here. These are transition elements. They also have kind of a stair step thing going on here too. So all these things over here are all transition elements. So what's special about those or not special about those, whatever, however you want to say it, is that you can't just simply look them up on the periodic table. You have to guess them, and I'll show you how to do that in a little bit. So boron would be +3. That's boron and aluminum, gallium. Carbon has 4, and so does the rest of its family, valence electrons. So it ends up just sharing. It doesn't form these ions that like what we're working with today. And then we go the other direction. Nitrogen, these are nonmetals now, is -3. Phosphorus, arsenic, so on and so forth. Oxygen is -2. Sulfur is the same. Fluorine, chlorine, bromine, -1. And then finally we get to the halogen, or the noble gases, and they have full 8 electrons, so they don't interact with other elements. They just keep their 8 electrons. They don't steal, they don't share, they don't do nothing. They don't react. That's why they're called noble gases. All right, so this is going to be handy. You want to keep this handy. And then let's take a look at this polyatomic ion chart. I'm going to have you guys highlight this because it'll come in handy if you highlight it. These are common ions. Ammonium is common. Carbonate is common. Let's see. Hydroxide is common. Nitrate is very common. Phosphate is common. And sulfate is very common. So go ahead. You can pause your videos and see which ones I've highlighted here, and go ahead and do the same because it'll make it easier to find stuff. Now down here, they have the transition element charges. Like I said, you can't look them up, so copper. But you notice some of them form several different types of ions, so it's really best just to get that information from context. Like, for example, if you saw, if you saw iron, you know that chlorine becomes a -1 ion since there's 2 of them. This particular chemical is going to form, when you dissolve it in water, is going to form a +2. So you just get it from the context. Knowing that what the non-metal part is tells you what the metal part is, because it's all got to equal 0. Okay, so this one is about disassociation. Just to get you guys caught up, or some of the folks that missed a couple of days or whatever, you can go ahead and read this. I mean, it's pretty good. It'll kind of help you. but I think sometimes some students just want to get directly to the examples. So we can, for example, do the dissociation of calcium chloride. So if you take this as a solid and put it in water, the metal part, calcium, and the non-metal part, chlorine, splits up. Now, this literally means that for every one calcium, there's 2 chlorine atoms in the crystal. Okay, so that's really important. Now, when you split up, you have to still talk about the ratio of calcium and chlorine in the water for this to be a balanced chemical equation. But when you see this subscript, that means this whole thing is combined into one thing. If you saw chlorine 2 by itself, that means it's a chlorine molecule. It's 2 chlorines tied together. So the fact that it has subscript tells you that they're stuck together. This is really important. And I had a student kind of, give you a little hint. So when you start splitting these things up, if you have a polyatomic ion, that is the things on the list that we just highlighted, you do not, I can't stress this enough because this is the biggest mistake students make. Don't mess with the subscript. Treat it like it's its own element, because it's stuck together. The 4 stays. It doesn't come out to the front because it doesn't break up. It just stays its own thing. The metal goes off in its own direction. Like if it's, for example, if I had sodium sulfate, the metal stays its own. You get 2 sodiums there because of this. The metals go off in their own direction in the water, and the sulfate goes off in its own direction. Notice I don't bring this up here. Don't do that. No. If it was chlorine like this calcium chloride example, let me make some space. If it was this calcium chloride example, calcium Cl2, now there's a subscript that you're going to remove and put in front. You're going to say this is aqueous. That means it's in water. It's going to turn into calcium plus 2. The reason why I pick plus 2 is because it's in the second group in the periodic table. And then plus 2 chlorines, and the chlorine is -1. There's 2 ways I can figure out the fact that this is -1. Because calcium is plus 2, and there's 2 chlorines. I need these to cancel out, these charges to cancel out. Let me write this a little clearer. Oopsie. That doesn't work so well. Here, let me just come down here where there's more room. So, I don't know what's going on. This thing better not run out of gas. There we go. That's better. Okay, now we're back. So calcium chloride in water disassociates to plus 2. We can get that information from the periodic table. And then chlorine 2, it's acting weird again. 2 chlorine has a plus 1. Now this has no charge. You don't see any charges on it up on the like there's nothing here. So we assume that it's 0. That means these charges on the right side have to cancel out. So plus 2 plus plus 2, I don't know what it's, oh, little pencil thing, I gotta screw it back in. There we go, this should work better. Plus 2. Now this is plus 1, but look, there's 2 of them. So 2 times plus 1. I'm sorry, I meant to write -1. Let me fix that. Sorry, guys. -1. So let me clean that up. -1. Okay, so +2 plus -2, because you're multiplying -1 times -2, that all equals 0. So that's another way you could check your work. You don't have to do that, but you do have to put these charges here for the problem to be complete. Now let's do a couple more examples. I did sodium sulfate for you already. Let me do zinc nitrate, because that's a good one to show you what I mean by the... so zinc nitrate yields zinc aqueous. Now, because it's a transition metal, we don't know what the charge is. But we know that, remember, bring this out front, because these two whole things break up and go into the water as two separate nitrates. So you basically have NO3 twice, because there's two of them. That's what the parentheses mean. I'm going to clean this up here so you can see it better. So because I have two of them, I have to put a coefficient of 2, NO3, like that. Now, 2 times -1 gives me -2. Well, the metal is always going to be positive. That's easy. But how positive, how many? Well, you can guess now. It's going to be +2. So that's your answer. So that's your answer. That's how that disassociates. And I did this one for you as well. I think you guys are good, because this is kind of a little bit trickier one. These are easy. Yeah, I think I'll leave it at that. All right, guys, hopefully that helps.